Hello, welcome everyone to question number 5, page faults in LRU from the topic greedy in Geek for Geeks wants to do coding interview question. Have a quick look at the question and we're discussing the meaning and approach behind it. Before that, if you have any extra amenities, please do subscribe and support our channel. And if you have any doubt, just leave a comment down below and we'll be very quick to respond. Now let's continue towards the question. And I hope everyone knows the operating system topics. If we have know the operating system topic, then you must know the LRU approach used to find the page fault. If you don't know, don't worry, I will be making sure to remind you what it is. So in this question, basically saying is we have to find number of page fault. And what is a page fault? We will know soon by discussing the example. And this example, the capacity C is given. So whatever the capacity is there, we can only store that many elements only. So initial capacity will be 4, but elements inside that will be 0. Now we are going to check the page elements present inside this capacity or not. If it is not present, then that is a page fault. Okay, now let's iterate one by one. 5 is present. No, it is not there. Then we're going to make it appear. Okay, now 5 is there. Now we're going to update the page fault value. That will be 1 initially, because 5 is not present, the element is not present, then we say it is a page fault. So that's the meaning of the page fault. If the page we are searching inside the capacity, it is not there, we say it is a page fault. Now we have updated the value 1. For 0, 1, 3 also same. These three elements are not inside the capacity here, so let us add them here one by one. And for these three values we're going to add plus 3, one for each. Okay, one page fault for each element, so that makes 3 here. Okay, we're good till this part. Now main thing comes after this. Now we're going to search for two value is not there. Now we have to remove one value, and that decision is based on the LRU approach, least recently used value. That means whatever value has come at the start, that should be removed. Okay, the starting value that was in this list was 5, so 5 will be removed. That will make 0, 1, 3 and 2 will be inserted, because one new space is there now after removing 5. That is good. Now 2 is not there inside the list. For that we're going to count value 1. Now again for the next element 4, 4 is also not there. Count the value 1 and now delete the last used element. 0 will be deleted. So 1, 3, 2, 4 will be there now. So this will be our current capacity list. Good. Now coming to the next element 1. Okay, 1 is already present. Okay, that is good. In theory, you may not remove this one, but in practically, we have to remove this one value. We're going to remove this one value and we are going to place it on the top of the list, because one is a previously called value, but one is repeating again. That means one value is a recent one, very recent one. So we're making it from a least recently to a most recently element. So that's why we are removing the element from the least recently used to and adding it to a most recently used one. So this is a very important step. Okay, most of them must have been confused while doing this code at this point only because of this small mistake. Okay, I hope now you know what is the reason behind your mistake. Now after that, we're not going to add plus one here because one element is present. Okay, if the element is present already, we're just making sure that element is on the top of the list. Cool. Now coming to the next element 5, the next element 0. 0 is not there. Now we're going to remove the least recently used element, that will be 3. Now you can see that change here. If I haven't removed the 1 here, okay, if I haven't removed the 1, instead of 3, now 1 will have been deleted, which is wrong. So that's why you place it on the top, so it will avoid the conflict like this one. Okay, now 3 will be removed, 2, 4, 1 and 0 will be there, and this will be plus 1. 0 is not there, so we are going to add plus 1 here. So after this again 5 element is also not there. Remove the last recently used 4, 1, 0, 5. So this will be our final list capacity and loop will be ending after this, and we are going to add plus 1 because 5 is not there in this capacity. So total page fault coming out 4, 5, 6, 7, 8. So we have 8 page faults in this. 8 page faults in this example. I hope we have understood how we are counting the number of page faults. And the most important one is we have to remember the element already existing. We have to remove it and place it on the top of that list. So it will be considered as the most recently used element, or else it will be treated as the least recently used if the element is repeating itself. You have to keep this one important step here. I hope after this you won't forget the logic. If you still have doubts, let's go into the coding session. After seeing that, it will be very much clear to you. Now we're inside the Geek for Geeks website. Now as you can see, we have taken a list here, okay, to store the capacity elements, and we're taking count 0 to count number of page faults. We're iterating one by one page, and we are checking if the element is present inside the capacity, is there or not. So we are ensuring that only 4 elements should be there. If the container is full, whatever the next element is coming, that has to be stored. So we are removing the least recently used element, and we are appending the current element. So in this way it won't go beyond the capacity. Fine. After that, there's another condition else part. If the element is repeating itself like one in our previous presentation, we're going to remove that element. Can be at any position, it can be at the starting position also, it can be at the ending position also, we don't know that. So we're going to remove that, and we're making sure that it stays on the top of the list only. So this L dot append will make sure it will always stay on the top of the list. Okay. In this way, after repeating the loop, we are storing the count, and we will return this final count to the function. And this is our code. I hope you have understood the logic and code behind it. If you like the video, please give us a like, and also don't forget to subscribe and support our channel, which is very important to continue. Thank you for watching till the end. Let's meet in another question.